For my wet lab experiment, I decided to test acids and bases with the solutions that are here today using a pH indicator. But before we start the experiment, we gotta first know what does pH mean, what's a pH indicator, and what an acid and base is. The first things first, what is a pH? When going into this experiment and when researching it, I didn't know what pH stood for, but when I went into it, I found out that it means power of hydrogen. Since, power of hydrogen. Next is, what is a pH indicator? A pH indicator is a scale from, from 0 to 14, where 6 to 0 being from weak acid to a much stronger acid, which being at 0. And then from 8 to 14 being most alkaline. So we use this to rank up the solutions that we have here to put them in a certain rank note to figure out which is acidic and which is basic. And which brings up to another point of what acidity and alkalinity is. I kind of already explained it. Usually when something is more acidic, it usually has an increase in the hydrogen concentrations, which changes the colors of it. And it has a decrease of hydroxide. The opposite happens when you go into alkalinity, which is an increase of hydroxide concentrations, but decrease in hydrogen ions. Right now, we are trying to extract the indicator that we need to test the acidity. I have the boiling hot water here. I got the purple cabbage that we are going to use to extract it from. The reason why we're doing this is because the purple pigmentation that you see inside the red cabbage is called anthocyanins, which is a perfect indicator for any element to test any solution from either it's acidic or basic. All right. As you can see, I already poured in the hot water into the red cabbage. You can already see the discoloration over it, seeing from clear to at least, well, it's supposed to be lighter blue, but to a blue color. And that's me not doing anything to it just yet. Right. You don't want to blend it, too much. All you gotta do is put it at a certain setting. Have it pulsating until the full purple color extracts from it. But if it's not enough, then also you can then you gotta keep doing like this until you see it going into a much darker color. All right, is that good enough? Let me just a little more. Alright, that's perfect enough. As you can see, it went from a little bit darker blue to a purple color. This is perfect for what we need for an indicator. Now, you don't exactly have to put it in a blender with the hot water. You can also pour you can also put the cabbage into the pot with boiling water. That's one way to do it. I did it this way because it's a little bit faster, a little bit quicker to do it. But now it's time to remove the extract. Now it's time to remove the excessive cabbages in here. You can either use one of those paper coffee things that you use in coffee makers, or if you don't, you can use one of these strainers to strain out the excess cabbages in here. But if you still see large amounts of cabbage in it, then you can take it out with your fingers, but be careful it's hot. But if it's not, if it's as small as you see it here, then just use a strainer, a pitcher, and it's going to be fine. Careful when pouring it though. As you can see, it has that dark purple color to it. This is almost as perfect as can be. If you get it to a lighter purple, that'll be fine. But as it is, this is fine. Pause. Okay, once you finish straining into the pitcher, and you got all the extracts out of it and throw away the excessive, or probably use it for compost or whatever. Now it's time for the actual experiment. The first one and I put this in order of how I want to test it, leaving bleach for end because I have something to say about that. But the first things first, we're gonna use baking powder. But for this, you want to first dilute it in water, because if you straight up add the powder into the indicator, it's not gonna have much of a reaction. It will, but not the reaction that you might be hoping for. The first things first, you want to dilute it so you can have the perfect discoloration to see where it falls on the indicator. All right, come here. Look what happens when I first Look what happens when I pour the diluted baking soda into here. As you can see, it may not look like there's much of a difference in it, but it went from a dark to a lighter purple. But if you know your stuff, it is roughly more alkaline, and because baking powder or baking soda, it is more of the alkaline sense of it, roughly around maybe 10, or roughly around like 10 or 11 on the scale, not so much. All right, next. I'm gonna be using apple cider vinegar. I was thinking of using white vinegar, but then I saw that obviously I saw this different compositions, same process but different compositions, and it has 5% more acidic than usual. And I want to see what the color change of this is, and see how acidic it can actually be. Alright, let's see how it will turn out to be. Oof, look at that. Look at that neon pink color. As you can see, this should be on the 3.3 to probably 2 scale on it. In honesty, if it wasn't for the smell and didn't know what this was, I might think it might be a darker shade of pink lemonade, but you don't want to drink this unless you want the health benefits from it. But if not, then probably don't drink it. It's not gonna be good. It doesn't taste good. Next, we'll be using the egg. When going into this experiment, I was surprised by this, because when I researched which solutions I should use, I saw people use this egg. Doesn't matter if you have white egg, brown egg, brown egg, but doesn't matter. It should have the same results. I didn't think this was gonna have much of a chemical reaction, but it does, and it's the most surprising thing ever. Let's see what color it can actually change into. Okay, put the egg, like that. Mix it. As you can see, it may not be as noticeable, but as you can see, it's starting to turn into that lighter blue color, going into probably on a scale of 9 or 10. And you can obviously tell, since we usually eat this like on a daily basis, and if you watch any of the Rocky movies, you can literally see Rocky drinking this as a protein. Straight, like probably 6 eggs or whatever. But as you can clearly tell from the indicator here, it is very alkaline, which is good because we use it a lot in cooking. Obviously, you can notice the major differences from lighter purple bluish color to neon pink lemonade color to a murky blue color. Reason for this is because with this one, since it's more on the alkaline sense of things, it has an increase of hydroxide concentrations in it and a decrease in hydrogen ions in it, which tells you that it's very alkalinic, far from the neutral sides of things, because 7 is supposed to be the neutral number of it, which sits water, because water is the medium of all living things on Earth, and is 71 to about 95% of our cells, and for our body, roughly about 60% is what our body is made up of, which is a good medium. And if it's neutral, you know that it's gonna have a perfect blend of both H positive concentrations and OH negative concentrations. The next thing that we're going to be testing is a lime. I have it in and pour about like probably 4 lemons in here. No wait, limes. Let's see how the color will end up looking like. Look at that. Oof. Look at now that looks more like neon pink lemonade. Jesus Christ. Look at this. Come here. There's apple cider vinegar, and that's lemonade. This personally tells me that lemonade the lemon might be a little bit more concentrated, which gives us that much brighter color to it. And this one a little bit murkier because there's still other things mixed into here, but still very acidic. Again, health benefits and all that. Not really that important right now, but it's very interesting how even though both share almost that identical acidity levels, you can see that one's a lot more murkier than the other one. Next thing I will be doing is a mixture of both lemon lime soda in it. It may not be as acidic as this, but it will still give you that acidity look to it. Which kind of makes sense though, since soda is not actually that healthy, but it's good for a treat every once in a while. Alright, let's see what would happen if we pour this in. Ooh. Again, not as murky as the other, not as acidic as the other ones, which is usually, depending on the soda you get, it's usually around a 3.3, maybe a 3.5, but it's still pretty acidic. But too bad we didn't get Coca-Cola, because you can literally clean a car engine with it. I've seen it happen before. They're surprising, a little worrisome, but still good, still very tasty. But last but not least is bleach. Like I said earlier, I might explain why I wanted to have it last. Is because this right here is, if you already didn't know, it's a very strong base, and you don't want to mix it in with the other solutions. And the first things first, I'll show you what the coloration is going to be when I pour it in, and I will explain a little bit later why you don't want to mix it in with the other indicators that already have the solution in it. Look what happens when I pour it in. Look, wow, see that? I went from a dark purple to a very yellow pea-like color. And I got to tell you before, and if you already can't tell that, I can already smell even though I put a little bit too much, I can still smell that bleach coming from it, and it's very strong. And the reason why you don't want to mix this with any other solution is because if you mix something as strong as this into anything else, it will just straight up damage the pigmentations of it, and that's what you don't want to do. But for every other solution, it doesn't matter if you mix or match, it can change the color of it. Let me see. Okay, let me show you. Come here. We'll be using the soda, and we will be putting it in here to show you that change in color. Look what happens. This is the first one that we did. This is the baking powder. You can tell that it's alkaline, has a purple bluish color to it. And let me show you what happens if you pour in something acidic. You can tell it goes straight up acid right now. Same thing if I mix it in with anything else. But, and then like I said, you don't want to mix in bleach because it will just change and destroy any pigmentation that you see inside of here. That's it. As you can see, like I said before, I already poured in the soda into the baking soda solution. You can see it went from a dark, usually a purple blue color, to a lighter color shade of pink. It's a weak, like a more or less weak strong base with a 3.3 of an acidity. I didn't do much with the apple cider vinegar, but I actually did add bleach to the last three, and look at the drastic change it has. You can see from before how it can change colors between from from something that's very basic to something that's something that's little less basic. Acid, basic, acid, and very strong base. This is something that you don't want to normally mix because you already found indicators. But if you want to continue on with a little experiment with a little bit more to it, you can do this. It's fun, but I suggest be careful. This is very strong. The scent is very strong, and depending on the solution that you're going to be using, you don't really want to accidentally mix them together because you might end up making mustard gas, which is very poisonous. But that's it for my experiment. Thank you very much for watching, and that's a wrap.